Hi, everybody. Welcome to Chapter 12 Solutions. So, we learned in the beginning of the year that solutions are homogeneous mixtures. So, mixtures that are the same throughout. In the solutions chapter, you will realize this is chapter 12 in your textbook. So, you can go look in your textbook at myhrw.com, but you will realize that in solutions can be solids, liquids, or gases, and we'll get into that a little bit later. But there's a picture over to the left, over I guess it would be your left too. It's a picture of the Grand Canyon, and it says what causes the formation of limestone caves. It should be at the Grand Canyon, and most of us should know by now that erosion occurs because of water. So we're going to talk a lot about water in here. We're going to talk about solvents, solutes, solutions. We use solutions every day. Solutions, air can be a solution. We talked about that at the beginning of the year. A lot of things that we drink are solutions. Gatorade, soda, lemonade, those are called solutions because they're the same throughout. Now, a water is not a solution because it is still considered to be a pure substance. So if you look over to the left, aqueous solution, waters that contains dissolved substances. A solvent. So we call water the universal solvent because water dissolves a lot of things. It's the thing that does the dissolving. So if you look over here at C, you will notice that that is just a cup of hot tea. So the solvent in this situation would be hot water. Okay, so that'd be hot water. The solute is what's being dissolved. So in this case, what's being dissolved is the tea. So same thing if we're going to do a Kool-Aid lab next week. The solvent would be water and the Kool-Aid would be the solute. It's pretty common. Even in detergent, like if you go to wash your clothes, the solute would be the detergent, the water is the solvent. It does the dissolving. So the solution over here would be both the solvent and the solute combined. So this would just be, I would just call it tea. We just know that tea is made up of water. Okay. So it says solution mixtures. What's an example? Well, there can be lots of examples. One thing that can be an example is what we said here, tea. That's a solution. Ink is a solution because ink is actually made up of different colors, but it's the same throughout. So ink is a homogeneous mixture. Vanilla ice cream, anything that looks the same throughout would be an example of a homogeneous mixture. So I gave you two examples of liquids there, but I also want to give you, so these are liquids. I want to give you examples of things that are a solid, that are solids or are gases. So an example of a gas would be if you know somebody who scuba dives, gas in compressed tanks. So gas in compressed tanks. I'm trying to write with my mouse, so this is why it's taking longer. Because most of compressed gas or all of compressed gas has more than one type of gas in it. So if you're going scuba diving, you have two, maybe three different types of gases. There's going to be oxygen in there, definitely 21%, because you need to breathe, but then also nitrogen is mixed in there. The other is a solid, and we don't talk about this a lot, is steel alloys. Metals, brass is an example. They are a mixture of more than one metal, and they're the same throughout. Carbon-based steel, they put carbon in it to make it stronger. So those are examples of different types of solutions. So other types of heterogeneous aqueous systems are called suspensions. Suspensions is a heterogeneous mixture, so that's what's the difference here. And we know when we talk about heterogeneous, heterogeneous means you can see particles floating in it. You can actually pull the particles out physically with your hands. It makes basically a suspension is particles settle out. So you can see the particles, but they settle out to the bottom. So particles settle out. So examples of this would be salad dressing, because you have to shake salad dressing. So especially Italian salad dressing. So salad dressing. Another thing that you have to shake is paint. They paint particles settle out. Nail polish, you have to shake that. Muddy water, that should be an A right there, but I don't know if I can fix it. Muddy water. So those are examples because they settle out. I'm not going to even attempt to spell. Let's see. I'm trying to. There we go. Eraser. Muddy water. That should be an example of one there. There's also. I'm trying to think of other things that could be one. Well, you can write your examples down, but salad dressing, paint, muddy water, anything that when you shake it up, it looks really cloudy, but if you let it sit for a little while, it will eventually settle to the bottom and you can see a definite layer there. So a colloid is also heterogeneous. So these are both heterogeneous, but the difference is colloids, their particles do not settle out. So particles do not settle. So let's talk about some examples. Do not settle. So fog is an example. That's why you have to put your low beams on so that the light can be scattered below. So fog is an example. Milk is, so the difference is in a colloid is the particles are microscopic. You can't see them. You can see the particles in a suspension. So these are microscopic. So fog, milk, let's see what else. I had a couple more examples here. Smoke. Because they don't settle out. What else? Foam. So like shaving cream, gels, butter, jelly, those kinds of things. They all have particles in them, but they just don't settle out. That's the big difference. So let's talk about, it says homogeneous aqueous systems. So when we talk about an aqueous system, we're really just talking about that there is a solvent in all of these. So, your solvent is going to be your water. There's my water. Remember, so let's talk about what the differences are. Suspensions, the particles will settle to the bottom. So these are my little particles that are going to settle to the bottom. If I have a colloid, my particles are not going to settle to the bottom. They're going to be scattered throughout. In a solution, there are no particles that look different. They all look the same. So this whole solution will pretty much look the same. So let's talk about what the Tyndall effect is. So you can use the Tyndall effect to determine what is a suspension or a colloid. A Tyndall effect is the scattering of light so it's the scattering of a light beam, I should say. So what you would do is you would take a laser pointer, this is over here, and you would take your laser pointer and it would, in order to determine if it's a suspension or a colloid, it would pass through. Well, the laser is not going to pass through the suspension because it has no particles to scatter it. So it would shine through it would shine through in the colloid. So the beam of light would actually, if this was my beam of light, I don't usually want to use the same color, but if this is my beam of light, it would go straight through to the other side. It would actually, you'd be able to see it on like a white wall on the other side. If it was a suspension, it would never go through. It would be, it would stay within the beaker itself. You wouldn't see it come through the other side. So a Tyndall effect is a scattering of light beam. Better go back to blue ink. This should be. Let's get my pens together. Let's see. Light beam. As it passes through a colloid. Through a colloid. A colloid. Okay, that's good. Sorry for the handwriting. Okay, so next let's talk about things that what makes a solution dissolve quicker. And I think these are pretty intuitive. So if you're thinking about if you're making Jello, and honestly, people don't really make Jello anymore, you go buy it. But if you're making Jello or you're making something and it has a powder in it and you need it to dissolve quicker, there's some things that will actually help it dissolve quicker. So 3 ways to speed up dissolving of sugar molecules in sweet tea. One, like I'm gonna kind of go backwards. It says 1, 2, 3, but let's look at C first, and you can kind of see this the heat coming off of it. So if you want something to dissolve quicker, you're going to heat the solvent. So the hotter you make it, the more it will dissolve. So heat the solvent. So that's pretty intuitive. The next thing that you would do, and I'm working backwards again, is B. You would stir it. So that's why a lot of recipes ask you to stir things, because it will go into solution much quicker if you ended up stirring it. If you end up stirring it, and the faster you stir it, the more it'll go and it will dissolve. So the reason that is what you're doing is you're actually breaking up the surface area of the material. So when you're stirring something, you're making it smaller and smaller, and it's going through a process called solvation. And that's solvation. So solvation actually is where the water molecule can get to the solute particles much, much quicker. So looking at A, if you look down here in the bottom, I know it's hard to tell in this picture, but those are actually sugar cubes. We don't usually use sugar cubes anymore. Some people do, probably if you ask your grandparents. And sometimes you can find them in the store. But what you want to do in order to make that sugar cube dissolve faster, you want to break it up. So you can break it up, and again, just making the particles smaller. So break up. That is another way to speed up the dissolving process. So there's a couple different ways here. Heat up the solvent. So the hotter you make the water, the quicker the solute will dissolve. If you stir it, it will make the particle size smaller. Agitating it, it's making sure that the water gets surrounds the actual particles and breaking it up. Again, making the particles smaller. They're both similar. So now we're going to talk about different types of solutions. So solubility is the measure of how one substance dissolves in another. So when I say the word soluble, is something soluble in something, that means basically will it dissolve? So Kool-Aid is soluble in water because it dissolves. There's 3 different types of solutions we're going to talk about here. The first one we're going to talk about is a saturated solution. It contains the maximum amount of solute, okay, for a given quantity of solvent at a constant temperature. We make these in our homes all the time. I would say all the time, but an example would be when you make Kool-Aid. If you made Kool-Aid when you were younger and you put sugar in it, the sugar would actually, you would see the sugar at the bottom. And even though if you kept stirring it, you see the sugar. And when you have that layer of sugar, so the layer of sugar at the bottom of your Kool-Aid, so the layer of sugar mixed with your at the bottom of your Kool-Aid. Sorry about my handwriting. Your Kool-Aid. Okay. Unsaturated solutions, same example. If you're making Kool-Aid and you're putting sugar in it, but you don't see that layer at the bottom, it contains less than the maximum amount. So you can, it will, when you mix it, it looks like a homogeneous mixture. So it's just Kool-Aid. Again, it's Kool-Aid with no layer in the bottom. Now, a supersaturated solution is a little different because supersaturated solutions actually contain more solute than solvent normally. A couple examples of this would be fudge, because you have to, when you make fudge, you're heating up the chocolate and the sugar, and you keep adding sugar, and you get to a point, what happens is you add so much sugar, it looks like a nice liquid, but once it starts to cool, it takes on a different texture. Rock candy is an example. So fudge, rock candy. Rock candy is where you take water, you just keep adding sugar, because the more you heat up the water, the more sugar that the water can hold. So, and then once it starts to cool, what will happen is that the crystals will start to form either on a piece of string or on a stick, and it will cool over time, and it will make this nice, pretty crystal structure. So fudge, rock candy. Also another example, and I was reading about this, it's how people in the South make sweet tea. What they do is they actually make their tea warm first. They brew it and they make it warm, and they keep adding sugar in while they're heating it up, and then they let it cool. So that's what gives that extra sweet taste, is sweet tea. So those are examples of saturated, supersaturated, and unsaturated. Actually, on the next page of notes, I'm going to go over a graph on how to do the graph of saturated, supersaturated, and unsaturated, but I'm actually going to put it on a different video because this is already almost 20 minutes. So I will continue this on another video. Have a great day. Bye.